In today's lecture, we are going to see how the ER diagram is mapped to a relational model. So before going to the actual topic, let us understand what are the different terms used in this topic. So first of all, we will see what is ER model. So it's a pictorial representation of different entity sets and how they are related to each other. Now here the entity sets are represented by different set of attributes. Now here say attribute is nothing but the properties of the entity, and entity is nothing but the object which exists in this real world. So to represent the object we need set of properties, and that properties are nothing but the attributes. So in this diagram, to represent the entity sets and their relationship sets, different shapes are used. Now in this in this lecture we will see how to convert uh, composite attribute and multi-valued attribute in relational model. So before going to the mapping, we must understand different kinds of attributes. So here we are trying to map the composite and multi-valued attribute. So composite attribute is an attribute which is divided into several sub-components. Now while converting such attribute into relational model, some problem may arise. So while converting such attributes, we need to take different measures. Mm, for example, the composite attribute can be person's address or person's name. Now in this the name is divided into different subparts, that is first name, middle name and last name, and person's address can be building name, flat number, then sector number, city, pin code. I mean, according to your need, you can divide the address attribute into different parts. Now, while converting such attribute into relational model, the rule one is each attribute, while convert a relational model cannot accept the composite attributes as it is. So, each attribute must be a simple and single valued attribute. So if a ER diagram includes a composite attribute, then in while converting it, we have to convert the composite attribute into single valued attribute. Here the single valued and simple attribute which has atomic values, that means the attribute is no more divided into subparts. Such attribute obviously contains single value. So for each subpart, while taking in a relational model, we have to consider a separate column. So consider this simple diagram where a customer entity set has different properties. So customer ID, customer name. Again, customer name is divided into two subparts, that is first name and last name, then address, and the customer has many phone numbers. So this phone number, mobile number is represented as multi-valued attribute. Now see, in the above diagram, the name attribute is divided into two parts. First name, we can have three parts also, middle name and last name. So in this case, we cannot construct a column which has two sub-columns. So while converting this such composite column in a relational model, each subpart is represented as separate column in relational model. So if we are considering a column name and which has subparts first name, middle name and last name, then this type of table is considered as a bad design. Why? Because when you are taking such kind of attributes in a relational model, then the retrieval of such attribute creates a problem. Like in a situation, suppose if I want to retrieve first name, middle name and last name together, then in that case I may face some problems. So to avoid such problems, or if I want to retrieve the data of the employees whose last name starts with P, then in that case I cannot put a query on a sub component of name. So retrieval is very difficult. So to avoid this situation, it is very obvious that we should consider each subpart in a separate column. That makes the retrieval easy. Now this you can see that for a good database design, we have to consider each subpart of a composite attribute as a separate column. So in this conversion, we can see the customer schema has customer ID, which is a primary key, and then first name and last name. In the previous diagram, we saw these are the subcomponents of name are now represented as a separate column. So this can be considered as the perfect relational model for composite attribute. Now we will see multi-valued attributes. Now in the diagram, as I told you, you can see that customer may have multiple phone numbers. So to show the multiple values under one attribute, we represent such kind of attribute by double ellipse, and such attributes are called multi-valued attributes. But when we want to convert such multi-valued attributes in relational model, we may face some problems. For example, you can see that when I have such kind of attributes, then initially the developer may face a problem while deciding how many multi-valued attributes I have to consider. For example, suppose a person has two phone numbers, then other person may have three phone numbers. So in that case, it is very difficult to to design a table having three or two phone number values. So if I am taking two phone numbers, then there may be a situation where a person has third number. So in that case, there is a insufficient storage for the third number. And suppose if a person has only one phone number, then in that case there are chances of introducing too many null values. So to avoid such situation, it is advised to separate the multi-valued attribute into a separate entity set. Now, while converting the multi-valued attribute, we are having two steps. The first step is separate the multi-valued attribute into separate entity set. Now, second step is obviously the multi-valued attribute which is now represented by a separate entity set is a weak entity set. Now, weak entity set is the one which has no keys or no attributes to decide a primary key. So such entity sets are called weak entity sets. Now, so in the first step, we will separate the multi-valued attribute. Here you can see in this diagram, now the multi-valued attribute is separated in a separate entity set which is represented by double rectangular box. So this double rectangular box represent a weak entity set. And now you can see that this weak entity set has a single attribute which is mobile number, and the mobile number is denoted by a dotted line. Now whenever an attribute is denoted by a dotted line, it is called discriminator. Discriminator is what? Within an entity set, it is unique, but alone that mobile number cannot exist without a customer. Like if I would like to give you one example in the real world. Now in a mobile shop, you may get n number of SIM cards, but each SIM card has unique number, but that number cannot exist without a customer. So as and when the person purchase a SIM card, that time the person's identity identifies a SIM card. So without customer, without a person's identity, SIM card cannot exist, or the SIM number cannot exist in this real world. That's why the mobile number is denoted as dotted underline. So to identify this mobile number, we need that mobile number must be associated with a particular customer. So that is represented by this ER diagram. Here you can see that the customer phone, which is a weak entity set, has a total participation in the relationship set. Now here, whenever a weak entity is relying on a owner entity set, that is customer, the participation is always total, because the mobile number cannot exist without a customer. So whatever the mobile number exists, that must be associated at least with one customer. So that's why the participation here is denoted by double line, shows that the participation is total participation. Now here you can see the relationship set is represented by double diamond. Why? When you represent the relationship set by double diamond, it is called identifying relationship set. Now identifying relationship set indicates that the customer, that is strong entity to weak entity set, relationship cardinality is one to many, because one customer may have n number of phone numbers, or in other way we can say that number of phone numbers can be associated with one customer. That's why the cardinality between customer and customer phone number is one to many. So this is the first step while converting the multi-valued attribute into relational model. So here we separate the multi-valued into separate entity set. Now the second step is convert this weak entity set into strong entity sets while converting it into relational model. So for this, what we can do, we have two tables. One is a customer table which has attribute customer ID, which is a primary key, then customer name and address, and then in the another table we have a customer phone table which has a single attribute phone number or mobile number. Now this phone number can exist with the identifying or owner entity set, that is customer ID. So from the customer entity set, this customer ID is taking as a foreign key in customer phone, and now customer ID, which is a foreign key from customer, and mobile number, which is a discriminator, together form a primary key of the new entity, that is customer phone. So this way we can convert the multi-valued attribute into relational model. So that's it for the conversion rules. Thank you.